Hello again, biologists. This is a video coaching you through how to approach the redo question in your Unit 3 exam, and we're looking at question 1, part F. Okay, so this is a challenging part of the exam. I'll read it to you to start with. So it says, using the experiment as a guide, design an experiment that would support the type of inhibitor you have suggested PTU is. Present the results in the expected in a table. So just reminding you that this is the reaction that we're investigating. So we've got catechol, which is the substrate binding to catechol oxidase, and resulting in this substance that produces a brown colour. What I suggest you do is you actually draw out a cartoon style enzyme so that it helps you to keep in mind that what an enzyme looks like, where the active site is, where the substrate will bind, and then you can do this up here somewhere, and then what a competitive inhibitor will do and what a non-competitive inhibitor will do. So remembering that a competitive inhibitor, if this is the active site, a competitive inhibitor will sit in here and block the substrate from binding to the active site. Whereas a non-competitive inhibitor will bind somewhere else on the enzyme, which is actually what this one says. So PTU binds to copper ions, which binds to a location separate from the active site, so here. And what that will do is cause a change in shape in the active site, preventing the substrate from binding. So I would draw that as a cartoon up here to help you visualize and structure your response to the question. So using the experiment as a guide, design an experiment that supports the type of inhibitor you've suggested PTU is. I expect that using this information here, the fact that we're binding to a location separate from the active site, that you've stated that PTU is a non-competitive inhibitor, so therefore binds to a site other than the active site on the enzyme and changes the shape, preventing substrate binding. What you need to do is think about how we might test that idea. How are you going to prove that it's a non-competitive inhibitor? And what I suggest you do is you pause the video and you look through your Unit 3 Area of Study 1 notes and look at the graphs that we've got relating to inhibition. I'm just going to jump into the internet here and show you one of the ones that does pop up in your workbook. I'll just move my face down there. This, I don't know if it's exactly this graph, but a graph like this does appear in your Unit 3 Area of Study 1 workbook. And what it shows you is really important, is this is the normal enzyme reaction as you increase the substrate to a point. The reaction rate increases. Okay, so this is substrate concentration here. And as you increase, you know that you increase the substrate concentration, you increase successful collisions between the enzyme and the substrate, and therefore you increase the rate of reaction. And that's what happens in an enzyme catalyzed reaction. If you add an inhibitor that's competitive, then you've got something that's actually competing for that active site. And if the inhibitor binds to the active site, the substrate can't bind. But if you increase the substrate concentration so that it overwhelms the amount of inhibitor, substrate is going to collide more often successfully with that active site. And eventually you'll get to a substrate concentration which results in the reaction occurring at its maximum rate. So we can see that as we increase the substrate here, we're actually able to overcome the effect of a competitive inhibitor. However, if we increase the substrate concentration and the inhibitor is non-competitive, then we actually aren't racing for the active site. So you actually can't overcome the effects of the inhibitor because the inhibitor is still able to bind, and substrate binding will not stop that effect. So that's the experiment that you need to design. You need to be changing the concentration of the substrate. And if you increase the substrate concentration, you will overcome the effect of the inhibitor only if it's a competitive inhibitor. If it's a non-competitive inhibitor, then the inhibitor will still stop the reaction or slow the reaction considerably. So I've given you a very, very good clue about exactly what independent variable you're testing. The dependent variable remains the same. You're still looking for color change as an indication of the fact that that reaction has occurred. Pay close attention though to the fact that it is asking you to present the results in the table. So using this table as a structure, show me that you are controlling the experiment so you have some point of comparison. Show me the independent variable, show me the dependent variable, and then outline why, so what it is that you're testing. Okay, so justify the use of the independent variable, so increasing substrate concentration in that case, and what you'd expect to find if P2U is in fact a non-competitive inhibitor.